So this is a question that is taken from JEE Advanced 2018. So the question is from the topic 3D geometry. In my opinion, these are the questions which you should look for in your question paper. Generally, the questions from vectors and 3D geometry will be easy most of the times. So, so the same goes with this question. So they are just testing the basic concepts, the directional ratios, directional cosines, point of line of intersection, angle between two planes. They're just testing these basic concepts. So here in this question, you are given two planes and you're asked to write things about those two planes. So that's it. So a student with a good grasp over NCERT should be able to solve this question. So before going into the solution, I would strongly recommend pausing the video and giving it a try. So let us solve the question. So you are given two planes, 2x plus y minus z is equals to 3 and x plus 2y plus z is equals to 2. So the line of intersection of P1 and P2 has the directional ratios 1, 2 and minus 1. Okay. Now so we have to find the directional ratios of line of intersection. So the directional ratios of line of intersection will be the cross product of the directional ratios of the normals to the planes. So the drs of normal to the plane, this plane, drs of normal is 2, 1 and minus 1, just the coefficients 2, 1 and minus 1. Similarly, the drs to the normal, drs of the normal to this plane is 1, 2 and 1. So now if we want the drs of the line of intersection, we have to do the cross product of these two. So let us do that. I cap, j cap, k cap, 2, 1, minus 1, 1, 2, 1. This gives I cap into 1 plus 2 minus j cap into 2 plus 1 plus k cap into 4 minus 1. So this is 3 I cap minus 3 j cap plus 3 k cap. So the drs will be 1 minus 1 and 1. So if you take out 3, so the drs will be 1 minus 1 and 1. But in the option, it is given that the drs will be 1, 2 and minus 1. So option A is incorrect. Next, let us go to the next option. 3x minus 4 upon 9 is equals to 1 minus 3y by 9 is equals to z by 3 is perpendicular to the line of intersection of P1 and P2. So these are the drs of the line of intersection of P1 and P2 of that. So and here you have one more line, and from this you can find the drs of this line, and they are asking us to check the perpendicularity. So let us find the drs first. So this is x minus 4 upon 3 by 3 is equals to y minus 1 upon 3 by minus 3 is equals to z by 3. So the drs of this line will be 3 minus 3 and 3, 3 minus 3 and 3. So they are telling that this line of intersection and this line are perpendicular. So we have to multiply the drs and then sum them up. If they yield the value 0, then they will be perpendicular. So sum of product of drs is 3 into 1 plus minus 3 into minus 1 plus 3 into 1. So this is 9. This is not equals to 0. So these two lines are not perpendicular. So option B is also incorrect. Option C, the acute angle between the planes P1 and P2. So the drs of the first plane is 2, 1, minus 1. The drs of the second plane is 1, 2, 1. You are asked to find the acute angle. So you have this formula. If A1, B1, C1 are the drs of the first plane and A2, B2, C2 are the drs of the second plane, then the angle between them is given by this A1 square plus A2 square plus A3 square, and the mod gives you the acute angle B1 square sorry, a1 square plus b1 square plus c1 square, a2 square plus b2 square plus c2 square. So plug in the values. So this will be 2 into 1 plus 1 into 2 plus minus 1 into 1 upon root of 2 square plus 1 square plus minus 1 whole square to root of 1 square plus 2 square plus 1 square. So this will be 2 plus 2, 4 minus 1, 3 by, so this is root 6 into root 6. So that will be 6. So cos theta is equals to 1 by 2, which implies that theta is equals to 60 degrees. And according to the option C, the angle is 60 degrees. So option C is correct. Next option, option D. If P3 is a plane passing through the point 4, 2, minus 2 and perpendicular to the line of intersection of P1 and P2. So let the plane P3 is equals to AX plus BY plus CZ is equals to D. Now it is given in the question that the plane passes through the point 4, 2, minus 2 and perpendicular to the line of intersection of P1 and P2. So this passes through 4, 2, minus 2 and it is perpendicular to the line of intersection of P1 and P2. So it is perpendicular to this. So the drs of the normal to this plane will be A, B and C. drs of normal. So, and here we have found out 1 minus 1 1, 1 minus 1 1. These are drs of line of intersection of P1 and P2. So now this plane is perpendicular to this line. So the normal is parallel to this line. So ABC will be 1 minus 1 and 1. So P3, plane P3 will be x minus y plus z is equals to D. And it passes through this point. So plug in the values of the coordinates. 4 minus 2 is equals to D, which implies D is equals to 0. So the equation of the plane P3 is x minus y plus z is equals to 0. We got the equation of the plane. Now what do we have to check? Passing through line of intersection, then the distance of the point 2, 1, 1 from the plane. So we have to find the distance of the point 2, 1, 1 from this plane. So there is a direct formula to do that. So the distance will be, so if you have a plane ax plus by plus cz is equals to D and a point x1, y1, z1, the distance will be ax1 plus by1 plus cz1 minus D by root a square plus b square plus c square. This is the formula. So just substitute and we'll get the distance is 2 minus 1 plus 1 by root over 1 square plus minus 1 square plus 1 square. So that is 2 by root 3. So the distance is 2 by root 3. And option D says that the distance is 2 by root 3. So option D is also correct.